Welcome to the KontinuumLAB MIDI C-board build video and tutorial. Now, of course, I'm not talking about the famous Roly C-board here. This is the KLIK C-board. So C-board stands for capacitive keyboard, but really it's more sort of a generic capacitive surface instrument with a lot of freedom to set it up and lay out the keys any way you like, really. The C-board is also the instrument in the KontinuumLAB Instrument Kit series, which offers the most options and settings, like several different kinds of output, such as velocity, aftertouch, continuous volume control, and even Melodica Functionality. You can also transpose it up and down, and of course, as you can see, you can make it with different numbers of keys. So today I'm making two different versions of this beast. One has 16 touch-sensitive pads in a grid layout, and the other one has 32 keys in a more standard keyboard layout, and also incorporates pitchbend functionality. It's going to be awesome. Now, even if you don't have the KontinuumLAB Instrument Kit, you should still be able to make these instruments. You'll just have to source some stuff, some components yourself, and of course download the code from the link in the description. Both of these use the KontinuumLAB Instrument Kit Breakout board, but they can certainly be made without it if you have the skills. On the other hand, if you do have the kit, then you already have all of the sensor materials and components you need for either one of these, plus of course the microcontroller with the code already on it for these instruments and a bunch more. So if you want to get your own KLIK and come play along, then head on over to kontinuumlab.com where you'll find it in the shop. Okay, enough about that, let's get building.
So as usual, here in the middle we have the stuff that comes with the KontinuumLAB Instrument Kit, electronics, connections and so on. And then on the side here we have some construction materials, specifically this aluminum tape. It could be copper tape, which you also get with the kit, but because we don't need to solder on this specific build, I decided to use this aluminum tape, which works fine if you don't need to solder it. The corrugated polypropylene here is one of my standard materials for building. It could be cardboard, but in this case I'm using this fluted plastic here. So first we're going to make the main body of the instrument out of this fluted plastic here. And as always, I'm using my standard technique here of removing some of the corrugation on one side. I have a spacing of about 3 centimeters on the sides that will make up the walls, and then about 10 to 12 centimeters on the longer sides. And then I'm slicing down one side of the corrugation sections here so that I can bend the material quite easily, and then I'm removing the surplus material within that bend. And that will allow me to bend this material inwards and get some really nice round bends there on the outside, just like that. So then next I'm fixing these bends in place by applying some hot glue. And it might be a good idea to score the inside of these bends before you make them, which will help the hot glue to have some more surface area to hold on to. And indeed, I am doing exactly that here on the next bend. The first one I made is a flap that's going to help hold everything shut. You'll see how that works in a second. And then the second one is just a bend between a wall section and the top section of the instrument. So we apply some hot glue and then we just hold everything in place until that sets. And it gives a pretty solid structure. Again, I'm scoring this other bend over here and applying the hot glue. I'm leaving one of these bends free of hot glue, and that's going to work as a hinge when I want to open up and close the instrument, like that. Oh yeah, okay, so I can see I made the lid part here a little bit too short. So I'm going to apply some fresh hot glue to one of these bends. That's going to partially melt the old hot glue, and then I can adjust that angle to make it a little bit more open, and that's going to bring that edge closer to the flap. I hope you see how that works. Just working with what I got, improvising a little bit here, and that indeed worked just fine. So now I'm marking out where I want my pads to be here on the top. Of course, as I mentioned here, I'm not making a keyboard shape. Instead, I'm using the 16 contacts that I would normally have on a 16-key keyboard to make this square-shaped pad instrument. All of the electronics are still exactly the same, but this is going to be a different surface layout. So then I'm marking and making holes where all the cables will fit through, and you can see me expanding them a little bit with this twisting motion. That's because I need to fit the heads of the DuPont cables through there. So the contacts here on this instrument I'm going to make with no soldering, and I'm going to do that by using these thumbtacks, and they plug into the DuPont cables nicely, as you will see in a second. And I want it to be a little bit tactile, so I'm making these square cardboard pieces, and I'm going to put the aluminum tape on those, and that's going to raise each pad slightly off the surface of the instrument, making for a more tactile surface. Good. So now I have these square pieces of conductive pad, and I'm going to put my thumbtacks through those. And the thumbtack contacts directly with the metallic tape. There's no soldering involved. Also, we're just going to plug the thumbtacks, as you'll see in a second, plug them directly into the DuPont cables. So this is a very simple construction technique. Next, I'm preparing the dielectric layer that goes on top of each of these pads. They are, of course, capacitive sensors, so I need to isolate the conductive part from my finger when I touch them. It's the electrical field that of my body that affects the sensor, and so we need a dielectric layer on top. And I'm using this gaffer's tape here, which works just fine for this purpose. And so now I have the finished pad. So that's how that fits onto the instrument. But then as soon as I saw how that looked, I decided that I didn't want that gaffer's tape. It was a little bit ugly, and instead I took out this Kapton tape here, which has a nice sort of golden color to it, and is much thinner also, and so I'm applying that instead. And as you will see in a second, I'm going to use this Kapton tape on half of the keys, and on the other half I'll use some standard transparent polypropylene tape, and so I'm going to lay those out in a grid pattern. It's gonna look great, you'll see in a second. So first I do half of them with the Kapton tape, and then I grab this standard transparent tape and I do exactly the same with the other half. These tapes are also thinner than the gaffer's tape, not that it really matters for this application, but they will give me a little bit more sensitivity than the gaffer's tape would. And of course I'm being careful here to fold it over the edges. I want to make absolutely sure that there's no chance that I will contact any of the metallic tape directly with my finger. So yeah, there you go, that's all 16 of them. And now the next thing is to prepare the pads. I need to apply them to this surface here. But first, of course, as always, I'm going to number these. And so this is, well, I mean, you could number these any way you want. I just sort of actually changed my mind here in the middle. Just trying to decide where I want the low notes and the high notes, so to speak, to be. And that's going to define how I connect everything to the multiplexer.
So that's how I lay out the 16 pads. But what if I wanted to make a standard keyboard layout instead? Well, then I just do that. There's no difference at all other than the way the keys are placed. The software is set up to simply play a chromatic scale across 16 notes. It doesn't care where you put each note or each key or what shape it is. So here's how the keyboard version would look.
Okay, so now that I've finally settled on some way of doing that, I need to pull the cables through here and connect the pads. So in this case, I'm starting with all the cables, and then I'm going to connect the pads afterwards. So as you can see, these holes here are maybe just a little bit too small for the cables, but I make it work. So then I can plug the pads into the DuPont cables. This is exactly the right size thumbtack to be able to plug them directly into the DuPont cables and make a nice solid contact. So that's what I'm doing here. You can just twist them around a little bit and then they plug in very nicely. And you can see how I've laid this out in a grid pattern by color. And hopefully you will agree that that looks really awesome, and I'm really happy with it. So then what I'm doing next is I'm gluing all of these pads down. I'm pretty happy with the layout, and this is just so that I can stabilize them a little bit. I mean, they would probably stay in place without the glue, but I'm pretty confident that this is going to work just great, and so I just stick them down directly. This is also going to fix the cables in place. I probably won't be able to recycle these cables for something else, but that's fine. This instrument should last for a while. So next I want to place the electronics in here, and I just want to make sure that I'm able to close the box and that none of the cables interfere with the breakout board and the microcontroller. And so I just test a little bit the placement and then glue the breakout board down directly inside here. Then I connect the multiplexer with one of these 8 contact DuPont cables. I also glue the multiplexer in, and as you can see, rather than glue that down to the base, I'm gluing it up to the side wall here. That's going to give me easy access to the cables as I start to connect all of the individual sensors. Now, as I mentioned, of course, I numbered all of these sensors, so that makes plugging them into the numbered pins on the multiplexer very easy. Although, of course, the order of the pins here is basically whatever you want, because it's not laid out in a keyboard structure or pattern. So this is how I did it. You might want to do something else. Okay, so now I'll just close everything up just to see if it all makes sense and everything fits together. Indeed it does. And the next thing I want to do is apply the calibration button. Now, because I have a semi-open instrument body here, I'm going to install this on the inside. And that's why I picked out this particular button module, which has the pins going off to the side. So then I'm just going to glue that module down on the inside with the pins pointing into the instrument. And once that's set, I can plug in this cable here and connect it to the calibration button connector on the breakout board. And then we close that up again. And yeah, that's looking pretty solid. All that's left now is to connect this to the computer and see if everything works. Except, as I'm just about to realize, of course, I'm forgetting the selection jumpers. I need to make sure that the software knows that I'm making this C-board instrument with 16 pads. And so I just plug those in, and now I'm ready.
First we calibrate. Right now the output is set to velocity, so there's a note on signal, and then the note decays depending on the settings in the synth. That works like this. Okay, but let's find another more fitting patch. And now let's check the sensitivity. Cool. Of course there are other output options as well. I'm especially fond of the continuous volume control, but we'll save that for the second build, which is coming up next, so stay tuned for that. And there you go, the pad instrument works great. But why would we even want to lay out our instrument in a grid instead of a nice keyboard pattern where we can clearly see what note each key represents? Well, I don't really know, but people play these things. I would generally tend to use this kind of setup for percussion, I guess. But of course the KLIK software isn't set up specifically to match MIDI drum patches as far as note numbers and all that stuff. If you have the skills, then you can go into the code of the C-board and change the note outputs easily enough. But of course, if you're working with the pre-programmed microcontroller in the KontinuumLAB Instrument Kit, then it can also be solved by changing or even MIDI learning the notes in the synth directly. Whatever the case may be, keep in mind that this instrument has the same options and settings as it would have if it were shaped like an actual keyboard. I'll get into that more in depth in the companion video to this tutorial, so go check that out for more info. For now, we'll move on to the next build, which is a keyboard with a more traditional layout. Let's get started.
So, as you can see here in the middle, we have the same stuff basically as before, but there's twice as much of it because we're making a 32 sensor C-board this time. And then over here on the side, we have some construction materials. Maybe the main character here is these 3D printed end sections that I call box ends, that you can download from the link in the description, and they're very similar to the ones that we used in the Melodica tutorial, except a little bit larger. These sizes are interchangeable. You could make a smaller or larger C-board prototype if you want it. We also have various types of adhesive tape, and then of course this large sheet of corrugated polypropylene here, which is going to form the main body. So as usual, that's the first thing that we're going to start making, the main body, and I'm going to use this box and this 3D printed piece here to measure out where I want to make the bends in the polypropylene. I'm serious about this. I don't actually use a ruler for this because I need to define the bends by the corrugation in the material. But you can see the width here more or less. And so then I'm just like I did in the previous build, marking 3 sets of lines that are going to define the pieces of corrugation that I'm going to take out in one side, just like on the last one. That's the final cut, that's defining the width of the actual piece. So then, just like on the previous build, I'm reducing the length of the Stanley knife blade here to a minimum, and I'm cutting just one side of the corrugation. And that's of course going to allow me to make these nice bends. Except that I want to bend it the other way. So now once I'm finished with all the cuts, I'm going to remove that surplus material. Just repeating the technique from the previous build, and that's going to put those bends on the inside, just like before. The difference here, of course, is that we're going to bend this piece around the box ends. So that's going to give it a much more polished final result that you'll be able to appreciate in a little while. What you see me doing here is sort of struggling a little bit with the material. This, for some reason, this blue polypropylene, which has the same measurements as the black stuff that I used in the previous instrument, is a little bit tougher and harder to bend. So I'm not sure what that's about. Now what I'm doing is I'm removing a small section of the end flap here. That's the one that's going to go inside the instrument. You will see what that's about in a second. This is about 3 millimeters wide. The section that I'm removing, and that's going to allow me to do this. So that flap is going to actually be inside the instrument when I close it up. You'll see how that works at the end. And then I'm just getting rid of a little bit of surplus material here. And then just like before, I'm sort of scoring the inside of those bends, which is going to help me once I glue it all together to keep it glued. Especially in the case of this blue stuff here, which is a little bit tougher and harder to bend. I really need the hot glue to have some good surface area to hold on to. So this time the glue job, of course, is a little bit more complex because I both need to solidify these bends here on the inside with some hot glue, but then I also need to make sure that everything fits perfectly onto the box ends. So okay, that's the first bend made, and that's going to make the application of the box end a little bit easier. So for that, I'm just putting some hot glue here on the inside of this interior edge here, and that's going to fit in with the scoring that I made around the edge of the polypropylene, and that's going to hold it in place pretty solidly. So that's one side. Then I apply the other end, exactly the same operation, trying to not use exaggerated amounts of hot glue because it'll just sort of spill over and stick everywhere. Okay, so that's actually looking pretty good. So I still need to glue one more side of the polypropylene to the box ends, and then the last two sides, of course, are going to be the lid and the inside flap that helps to keep everything shut. So let's see, I'm going to do this all together in one. Get some hot glue on the interior bend and on the box ends, and then just squeeze everything together and hold it in position while it sets. This is sort of the most delicate part of the operation, but it's very doable, actually not that complex. Okay, so now the glue is set, and now you can hopefully see what I meant with the interior flap there, how it fits inside the instrument and keeps everything in tension so that the instrument stays shut. And with that, the main body is ready, and I'm going to start measuring out where I want the keys to be on the keyboard here. Now, of course, before I even made this instrument body, I had already decided how wide the keys were going to be, and they're about 18 millimeters wide, or that's the space that each key has. And then I'm leaving about 1 millimeter in between each piece of tape. So that's what I'm measuring out here. of course, there's a full row of white keys on one side, and then those intermittent black keys on the other side in groups of 3 and 2, just like on a regular keyboard. So I'm just measuring out all of those spaces. That's going to make it much easier to apply the conductive tape, and then of course the dielectric layer on top. So first, of course, is the conductive tape. And as you know, I'm partial to using the instrument to measure stuff rather than thinking in centimeters and whatever. So I decided these were going to be a little more than 4 centimeters long, these keys here, which will mean that they have a little bit of area around them so that they don't overlap. Of course, that's very important. And of course, not only should they not overlap, but they should indeed have a little bit of empty space in between them, because otherwise you're very likely to touch one of them with the edge of your finger when you touch the one next to it. So the width that I ended up with is somewhere between 9 and 10 millimeters, which of course is going to give me somewhere between 8 and 9 millimeters of empty space in between each, which works fine. They could actually have been a little bit narrower. If I had to change something and go back and do this again, I would make them a little bit narrower, maybe like 6 millimeters wide. But yeah, this is what I went with, and it works very well, as you'll see at the end. So then I'm just applying all of these pieces of tape here, and you can see that I'm trying to make sure that I get them on there in a regular fashion. And then of course I'm marking out where I want the black keys to be, and then I'm going to once again apply those as well, just in the same way. And as you can see, there's a little bit of empty space also in the lengthwise direction, and that's just as important as in the width. And there you go, that's the last of them. All 32 keys have now been applied. So now it's time to make the holes where the cables will go through, and I'm decided to make those down the middle of the instrument, where on previous prototypes I've made the holes on the side wall and then pulled the cables up. I decided to try this. It could really be anywhere, that hole, but I think this is going to be more neat, and it's going to keep all of the cables centered in one zone of the instrument. So then next I'm grabbing these 300 millimeter long DuPont cables, and I'm cutting them down the middle. And so as you can see, that's much shorter than the instrument, so these cables won't be able to reach from a key and down to the end of the instrument. But that doesn't matter, because I'm actually going to put the multiplexers each in one half of the instrument, and these cables will be long enough to reach from all the keys in that half of the instrument and to that multiplexer. So you'll see how that works in a second. Of course, I'm stripping the ends of the cables and getting a little bit of solder onto each, which is just going to make the solder job so much easier once I get to it. And then the next thing I do is I also get, of course, a little bit of solder onto the copper tape on the instrument. Now this is very quick, and you want to be very quick about this, because if you keep the soldering iron on there too long, you're going to melt the plastic underneath the copper tape. But this copper tape is extremely easy to solder to, and so it works quite fine. Also, if there is a little bit of deformation on this plastic underneath the tape, it really doesn't matter very much. Okay, so now of course I need to try to number all of these keys, and it's a little bit complex here from the inside of the instrument, where I can't actually see the keyboard, but I eventually figure it out. Okay, so now it's time to start applying the individual cables here. So I just take the end, the stripped end, and I push that up from the inside, and then what I want to do is solder it to each key. It is a pretty simple operation, made easy by the fact that we have a little bit of solder both on the cable and on the tape. So you only need to put the soldering iron on there for a very short while, and make sure that the cable is flush with the surface of the tape, so that you don't have a big solder blob on there. And yeah, that looks pretty good. I'm happy with that, and now I just need to deal with this whole mess of cables here on the inside. And of course, as I mentioned, those will be plugged into these two multiplexers. So I need to make sure I get those in a good position to have access to plug in, and also have access to the cables afterwards. But there's actually one thing that I almost forgot, and that's I need to apply 2 more sensors here, which are going to be for pitchbend. And that's one of the cool things about the C board. You can use capacitive sensors just like the keys to make pitchbend sensors, and that's what I'm going to do right now. You'll see how those work in the end when I play the instrument, but for now we just need 2 more sensors on here. Nothing to it really, it's exactly the same as the keys, except I'm making them quite a lot smaller and I'm putting them right next to each other. Of course, gliding your finger between one and the other is going to make the sliding action that defines the pitch bend, as in pitching up or pitching down. So I need some longer cables for this, because those aren't going to be plugged into the multiplexers, rather they're going straight to the breakout board. And so I'm using one of these male to female DuPont cables here as extension cables, and I'm just going to stabilize the middle connection here with a little bit of sellotape. And then of course, just like before, I'm stripping the ends, then I will tin the ends with a little bit of solder, and then I'm going to solder them. I'm going to pull them through from the inside and solder them to those 2 new sensors that I just made. And there you go. The operation is exactly the same as for the keys, except these sensors are a little bit different, a little bit smaller, and that's exactly as I wanted. Okay, now let's get serious about these multiplexers. So many cables in here, but don't worry, it'll be fine. What I do want to do now that these cables are soldered onto the sensors, I'm actually going to put a little bit of hot glue on the inside at the base of each cable, just to stabilize them, because I'm going to be moving them around a lot and I don't want the solder joints to move too much. So now I'm applying these 2 cables here. These are 8 contact cables. I'm applying those to the multiplexers, and those are going to be used to connect them to the breakout board. And then before I glue the multiplexers down, I'm going to plug in all of the individual sensor cables, and so that's going to help me to define where I put these multiplexers inside the instrument. And this needs to be thought about a little bit. Don't just hurry and stick them down wherever. Good idea to think about these things a little bit so that we don't get the cables tangled up too much. And yeah, so I don't claim that this is neat in any kind of way, but what I am trying to do is to keep all the cables that are connected to the separate multiplexers more or less separate. And then I'm plugging in the 2 additional sensors up from the pitchbend area. And that's fine for now, so then I can just close everything up and get started on the dielectric layer. So yeah, I decided to use gaffer's tape for this, and I have these 2 rolls here. We have a silver color and black color, which are going to be the white and the black keys. And they have exactly the right width to be the length of the keys and perfectly cover up the copper tape, so that makes everything a lot easier. And then I'm cutting them to that more or less 17mm width, so that I can cover the 18mm wide spaces that I drew on the keyboard and leave a little bit of a gap in between each key, which is going to help as a visual guide to where the keys are, and which is also just going to give a little bit of tactile feeling for where your finger is on each key. And there you go. So that's all the white keys, and next come the black keys, and that's exactly the same operation, except, you know, I don't need quite as many of these. So I find the best way to cut this tape, or any kind of tape, is to stick it down on a hard surface and then cut it on there and then take off the individual strips from there. Much easier than trying to freehand cut it or do it like in your hand with a pair of scissors or something like that. That's just going to get you in a lot of trouble. So as you can see, I'm slightly overlapping the gaffer's tape here, and that's just so that I can cover up the ends of the cables. And then I'm just cleaning off with a little alcohol here the remains of the initial lines that I drew to mark out the keyboard. And then here I'm actually checking if I can fit one of these bottle tops inside of the instrument, because I don't know if you noticed, but one of the box ends here has a hole in it for an air tube, and that's because this instrument can be turned into a melodica, as I will show you in a second. Anyway, so before I do that, I want to fix the breakout board in place, and the way I do that, of course, is to first plug in the USB cable through the hole that's in the box end for that. Then I apply a bunch of hot glue to the breakout board on the back side, and then I fold the inside of the instrument down over it. And then when the glue sets, I can pull out the USB and now the breakout board is in the perfect position to be able to plug that USB in again. And then of course I'm happy with the placement of the multiplexers, so I'm ready to glue those in as well. And that's how that goes. Okay, so now I just need to apply the calibration button, of course, as always, and these box ends here have a cutout for that, which makes it very neat. So I'm just putting that on the inside and applying a drop of hot glue to make sure that it stays in place. And then of course I can just grab the double cable here, double DuPont cable, and plug that from the button module and into the breakout board. Great, so yeah, like I mentioned, the final touch here is turning this into a melodica, if you so desire, by inserting a breath sensor. And as you can see here, I'm using this cool 3D printed breath sensor, which if you want to know more about it, I recommend the Ocarina tutorial or the specific Melodica tutorial, and of course the breath controller tutorial where I cover this in much more detail. And I will show you how to connect that in a second in the connection graphic. I also need to insert these selection jumpers just so that the KLIK software knows what kind of instrument I've actually built here. So it knows what sensors to read and all of that. And the final touch is very optional. The box ends here have these holes for M3 screws, and if you insert one of them through here, then it will fit inside the corrugation of the interior flap of corrugated plastic, and it will hold that structure very much shut. As you can see here, it's now totally impossible to open, but I find that this kind of construction is perfectly capable of holding itself shut without applying any screws. So yeah, very optional. Final thing, of course, is as always to plug this into the computer and see if it all works.
First, we calibrate. Okay, as promised, I already set this version of the C board up for continuous volume control, so we can see how that works. Works great. Now there's a lot to say about this playing mode, but I'll get into how it functions in much more detail in the companion video for this tutorial, so go check that out if you're curious. But before we finish, of course, I need to check the Melodica functionality. The breath sensor is already plugged in, but it's being ignored by the C board because of its current settings. So let's change those. Okay, now let's give it a go. Yeah, that works great. I don't mind saying it, I love the C board. It's so surprisingly powerful considering how relatively simple it is to put together. And if you don't want any of the fancy stuff like pitchbend or breath sensor, then of course you don't have to include that. But if you do want to, then it's easy to add even to an already finished instrument. And like I said, if you want to know more about the options and different playing modes and how to calibrate and play the C board, then there is a companion video to this tutorial which goes more into depth about that. The companion videos are published shortly after the tutorials, so you'll find a link to that down in the description. And that's all I have for you this time. You can go check out the rest of the build videos and tutorials for the KontinuumLAB Instrument Kit right here on the channel. And don't forget, you can buy the complete kit plus various types of KLIK instruments over at KontinuumLAB.com. Take care until next time, and I'll see you in the Kontinuum.